We're going to find the arc length of f of x equal to e to the x over the interval from 0 to 1. And let's recall that the graph of e to the x looks like this. This is the graph of f of x equal e to the x. When x is 0, y is 1. When x is 1, y is e. And so we're interested in finding the length of this piece of the exponential function e to the x. And recall the formula for arc length is the integral from a to b of the square root of 1 plus f prime of x squared. In our case, f of x is equal to e to the x. So f prime of x is also e to the x. And a is 0 and b is equal to 1. So we want to evaluate the integral from 0 to 1 of the square root of 1 plus e to the x squared is e to the 2x dx. We'll do this by two-step process. The first step is to make a u substitution. Let u equal to e to the x. When x is 0, plugging in 0 for x, we get e to the 0, which is 1. U is 1. And when x equals 1, u is equal to e. And du equals e to the x dx. But e to the x is u. So we have du equals u times dx. Therefore, dx is equal to du divided by u. Now let's replace the 0 and the 1 with 1 in e. This will be equivalent to the integral from 1 to e. We have square root of 1 plus u squared, and dx is du over u, so we can put u in the denominator here and du. Now this integral can be solved by trigonometric substitution. So let's put aside the 1 and the e and find antiderivative of square root of 1 plus u squared divided by u du. We're going to make the substitution that u is equal to tangent theta, so that du is secant squared theta d theta, and 1 plus u squared is equal to 1 plus tangent squared of theta, which is secant squared theta. So we return to this integral, and 1 plus u squared under the radical is now secant squared theta. In the denominator we have u, which is tangent theta, and then times du, which is secant squared theta d theta. And this is equivalent to the square root of secant squared is secant. Secant times secant squared is secant cubed theta divided by tangent theta d theta. Now, to evaluate this, there's really no one predetermined way to do it. We have to kind of do a trial and error. We could change the secant cube to 1 over cosine cube divided by tangent, which is sine over cosine, but probably that's more difficult. Here's probably the easiest way to evaluate this integral. We're going to take the numerator, secant cubed, and write it as secant theta times secant squared theta divided by tangent theta d theta. And then we replace this secant squared with a trig identity. So this is secant theta times secant squared, which is 1 plus tangent squared theta divided by tangent theta d theta. And this gives us the integral of secant theta plus secant theta times tangent squared theta divided by tangent theta. And let's write this as two separate integrals. The first one is going to be the integral of secant theta over tangent theta d theta, plus the second will be secant theta times tangent squared theta divided by tangent theta d theta. Now let's simplify this. In the first integral now we can express secant as 1 over cosine divided by tangent, which is sine theta over cosine theta d theta. You can see that cosines will cancel, plus the second integral, tangent squared over tangent is tangent times secant. So the second integral is the integral of secant theta times tangent theta d theta. Now the first integral, after canceling the cosines, we have a 1 over sine, so that's equal to cosecant theta. And the second integral is secant theta tangent theta d theta. Now you should know the integral of cosecant without rederiving it, and the integral, of course, of secant tangent. The integral of cosecant is natural log of absolute value cosecant theta minus cotangent theta, plus the integral of secant tangent, which is secant theta. Now we have to express this in terms of variable u. Our substitution was u equal to tangent theta. So we can draw a right triangle with this angle theta. Tangent is opposite side over adjacent, so that's u over 1, that's u. Then the hypotenuse is 1 plus u squared. So expressing the solution, we have natural log cosecant, sine is opposite over the hypotenuse, so cosecant is hypotenuse over the opposite. That would be the square root of 1 plus u squared divided by u minus cotangent. Tangent is opposite over adjacent. Cotangent is adjacent over the opposite. That's 1 over u plus secant theta, and secant is hypotenuse divided by the adjacent, so that is the square root of 1 plus u squared. And now we want to evaluate this from 1 to e. Let's plug e in, and we have natural log of absolute value of the square root of 1 plus e squared divided by e, and then since this is minus 1, we can write it right there because they have a common denominator of u, plus square root of 1 plus e squared. Now minus, let's plug in 1. So this is natural log of absolute value. We have square root of 2 minus 1 divided by 1. So it's square root of 2 minus 1 plus square root of 2. Now we just want to simplify this. This is equal to, we can drop the absolute values because everything is positive. This first natural log is natural log of square root of 1 plus e squared minus 1 minus the natural log of e plus the square root of 1 plus e squared minus the natural log of square root of 2 minus 1 minus the square root of 2. And then one thing we can simplify, natural log of e is 1, and we can write the final answer as natural log of the square root of 1 plus e squared minus 1 plus the square root of 1 plus e squared minus natural log of square root of 2 minus 1 minus the square root of 2. You can plug all that into your calculator and get a numerical answer. For more videos, visit www.mathprepvideos.com.